Pteropods are tiny planktonic snails that spend their entire lives in the water column. They're used as important bioindicators for the effects of ocean acidification on marine ecosystems because their thin shells are considered to be highly sensitive to changes in ocean pH. It's generally thought that the shell will start to dissolve as soon as it comes into contact with seawater that's lower pH and corrosive to calcium carbonate. However, they have a layer of proteins on the outside of their shell called a periostracum, and this layer hadn't received much attention in the literature. There had been a bit of debate whether or not it protects the shell from dissolution, and after reading this, I decided to design an experiment to directly test it. My results show that this layer does in fact offer some protection against dissolution and can act as a first line of defense against ocean acidification. We've known that species with a thick periostracum, such as deep-sea mussels at hydrothermal vents, are very resistant to dissolution caused by low pH. But now my results suggest that even species with an extremely thin periostracum might be more resistant than we previously thought. Whether or not species can adapt to changing ocean pH is unknown, but the periostracum gives present-day species one extra line of defense. Ocean acidification is happening much faster than any event we have evidence for in the past, and evolutionary adaptation is a very slow process. Species might not be able to adapt new defenses, but maybe traits that have been passed down through generations that have survived past ocean change can be put to good use today. The major pteropod lineages we see today survived through an event called Paleocene-Eocene thermal maximum about 56 million years ago, when the ocean became much warmer and much more acidic. And in fact, many new species of pteropods appear in the geologic record during this time. It is also possible that some species went extinct during this period. What it tells us is that at least some species of pteropods may be equipped to survive through events like this, although ocean acidification is happening much faster today. How species interact with their environment and ecosystem is an incredibly complex puzzle, and there are many changes occurring alongside ocean acidification today. The way pteropods have been used is to look at one metric, the condition of their shell, in relation to the pH of the water at the time of collection, and from that, to infer future impacts on full ecosystems. I think we should focus more on physiological responses, for instance, the energy required to build shells under future pH levels, and to develop a more holistic ecosystem approach, looking at a multitude of species over different trophic levels and multiple stressors, including warming and deoxygenation, in order to better predict future changes. Probably the most challenging part of this experiment was holding these tiny pteropods under a microscope on a ship moving like this while trying to gently scratch a layer of the shell that you can't even see with your eyes. So I had no idea if what I was doing was even working until after the experiment had ended and I looked at them under the microscope again.